All right, let's look at this problem here. I should write some directions, which are evaluate the limit if it exists. Evaluate the limit. Now, limits don't always exist. So let's see. Evaluate the limit if it exists. This limit here has a radical, as you can see. So this limit has a radical. And what are we going to do about that? So let's just try to figure that out. Now, first try to put in the number that x is approaching, which is 0. Then I get the square root of 0 squared plus 9 minus 3 divided by 0 squared. So that's square root of 9 minus 3 over 0, 3 minus 3 over 0. And that gives 0 over 0. 0 over 0 is not a number. I mean, it's undefined, but that is a form. So the form is 0 over 0. Okay. A method that I'm going to use, maybe someone has a different method, but the method I'm going to use when I see a radical is multiplying by the conjugate in the numerator and the denominator. So we multiply by the conjugate, and I'm going to sort of indicate what I mean by the conjugate anyway. And then I'm going to use this simple algebra formula, a minus b times a plus b equals a squared minus b squared. So I'm going to do that. Okay, so let's see if I have enough space after putting all that stuff there. Change the color to something a little brighter maybe, or something different. Okay, so let's check this out. What do I mean by multiplying by the conjugate? I am going to look at this radical, and the radical has a difference. It's radical x squared plus 9 minus 3. And what I mean by the conjugate is the same thing, radical x squared plus 9, but this time plus 3. That's what the conjugate is. There's different conjugates, but in this context with a radical, I have radical x squared plus 9 plus 3, while the other one has radical x squared plus 9 minus 3. And what I want to do is I want to multiply the denominator by that same expression. We do something very similar when we rationalize the denominators of a fraction. But that's, I don't know, we don't need to talk about that too much. Okay, anyway. So look, I'm using a minus b times a plus b is a squared minus b squared. So what is the a part? Well, the a is this x radical x squared plus 9, and the b is this 3. Right, so when I multiply, I'm going to get limit x approaches 0 of radical x squared plus 9 squared. Oh, got a little bit difficult to read. Squared minus 3 squared. Okay, that's what I get with the numerator, because I have a minus b times a plus b. That's what I mean by the multiplying by the conjugate. And the reason I'm doing that is because the radical when squared cancels. The radical and the squared cancel. Inverse operations. So now the denominator, I'm not going to multiply through. And the reason for that is that, in fact, my goal is to cancel out x squared. So I don't want to multiply through because I plan to cancel that out. So now, once we get here, I think we're essentially done if we're just careful about not making mistakes. The radical and the squared cancel out, as I said. So I have x squared plus 9, and then we subtract 9. So then we get 9 minus 9 is 0. So that's something. So it's simply simplifying. And at this point, the simplifying is not really that difficult. We've already done the sort of the big stuff. Okay, 9 and 9 cancel out. So then just trying to copy this down neatly. I have x squared in the numerator And then in the denominator, x squared also. So those will cancel. And then x squared cancels. What's left over is 1. So we don't want to just put 0 there. You know, x squared times 1. So 1's left over. And then I will, again, try to be sort of neat and write down this expression, 1 divided by radical x squared plus 9 plus 3. Now, see, the x squared was the problem that was making it undefined, but we can now put in 0. There's not going to be any problem. So now put in 0. Well, I don't think there's going to be a problem. No, there isn't. Okay, I can look ahead. So now put in x equals 0, and I get 1 divided by radical 0 squared plus 9 plus 3. Now it's up to me to get this wrong. It's very common for me and other people I notice to sort of relax too much and at the very end make a mistake. But I think we can do this. I can do it. Let's see. 1/6. Okay, so mission accomplished. Does anybody have a question on that or comment?
I do, actually.
Yes.
Does that mean that there's 2 different values then? Like if you were going to see it on a graph?
Oh, yeah, that's, you mean what does this look like? Well, there's definitely a hole in the graph. I mean, I guess this is going to look like this. I don't know what the graph looks like. So it's undefined when x equals 0. I'd have to, I don't know, I'd have to do some, would I have to think that hard? Hold on.
Like, sorry,
Okay.
What does this value mean though? Like versus.
Okay. First of all, this whole thing by doing algebraic manipulation simplified, but yes, I would say simplified to 1 over radical x squared plus 9 plus 3, but x is not equal to 0. So it has a hole at 0. And so what does this graph look like? Well, the function's always positive, and when x gets large, it's an even function. My guess is I'd have to think about it. We're going to do that in this class, sketching graphs, but I guess it's going to look something like this. But oh no, sorry, it's 1/6. So I guess it's going to look possibly like this. I mean, I can see it's going to. I think it's going to look like this. And so I mean, it has a hole in the graph when x is equal to 0. I'm not going to leave that up there because I didn't spend any time. I mean, this is not. I can't off the top of my head see what the graph looks like, but it's undefined. No, the original function is undefined at 0, but we simplify it to something that's not dividing by 0, but it still has that hole in the graph at x equals 0, and so that's how we found the limit. But we don't have the graph to look at. We did a bunch of algebra manipulation, but it looks like something like that, and that point there is 0, 1/6, where there's a hole. It's undefined at 1. It's 0.
Okay.
But I don't, we can look at Wolfram Alpha and actually try to find what that graph looks like. They'll tell us. I think they will. Okay, I'm going to erase that though, because I don't know if that's what it looks like. For sure. It's something like that, I think. Okay, so let's end this video.